Hi listeners, Benjamin here. Welcome to the Friday Briefing Show, where we talk about a few stories we've read about in the Nature Briefing, which is of course Nature's daily email roundup of the latest science stories. And sitting opposite me this week is Nick Petrichow. Nick, how are you doing today?
I'm doing well, Ben. I'm looking forward to getting into it.
Well, let's go then. Why don't I go first this week? And I've got a story that is based on a Nature astronomy paper that I read in Nature. And it's about a sweet discovery near the center of our galaxy, and it's all about sugar.
I am tasting the hint of a pun here with a sweet discovery and sugar. So what is this that they've found? Is this like sugar molecule somewhere or something like that?
This is exactly right, Nick. So researchers, it turns out, have been looking for sugar in space for a very, very long time. Yeah, absolutely. And there's been hints that sugars on Earth that are essential for life originated in outer space. So ribose, this 5-carbon sugar, was previously found on some very old meteorite samples, but sugar itself has been hard to find actually in the sort of interstellar medium between stars.
I see. And I guess this is a complicated molecule that would be difficult to just randomly come about. So interesting to find if it's out there.
Yeah, and this is a sugar called erythrulose. Now, it's a natural sugar found in raspberries and used in fake tanning lotions. Now, this is a 4-carbon molecule, right? So sugars, they have this kind of carbon backbone, and this one has 4 carbons. Now, a 2-carbon molecule was found back in 2000, this molecule called glycoaldehyde. Now, some folk would say this is the simplest sugar molecule. Other people would say it's not really a sugar. And so this is the discovery of a true sugar, in inverted commas, in interstellar space, swirling inside this cloud of gas and dust, as I say, near the center of our galaxy.
It's quite surprising to imagine that there's sugar out there. Did they have any idea how it might have got there?
Well, that's one of the open questions about this work, Nick. Potentially, it was produced through chemical reactions on tiny interstellar dust grains. Now, exactly how that happened is to be debated. But how it was found is interesting because it was this kind of combination of work between two groups of scientists. And what happened was a physical chemist in Spain shared some spectroscopic data about erythrulose. So these are kind of the specific fingerprints of wavelengths that a molecule emits. Think about it like a drawing of a comb, I suppose. Every molecule has its own individual comb. And so it's been quite hard to get this kind of data for sugars until relatively recently. And so this data was shared with a group of astronomers. And to their surprise, when they looked at their data of space, they found that this erythrulose fingerprint showed up in this molecular cloud near the center of the Milky Way. And they then used some other telescopes with deeper observations to see this thing more clearly.
And, I'm guessing I'm veering into speculative territory here, but does this have any relationship with life and things like that? Because obviously these sorts of molecules are really important for all sorts of chemistry involved in life.
It does get into speculative territory. But yes, this is kind of why scientists are interested in sugars more broadly. Now, these clouds are the birthplace of stars and planets. And the team say that if sugar exists in these clouds, it could be transferred to things like asteroids or comets as a star system forms. Now, Earth went through this period of very heavy bombardment of these asteroids and comets about 4 billion years ago. So it may be that sugar molecules were brought from somewhere else to the planet's surface, and potentially erythrulose could have provided a feedstock for the first nucleic acids, so very simple versions of the building blocks that then became the building blocks of DNA and RNA, if you see what I mean.
So what do researchers want to do next to try and peer into this a bit further, I guess?
Well, unlike the search for Spock, now we have the search for sugar. So these researchers are keen to try and find even larger sugars in interstellar space. Now, one of the questions is, why this one? They found a 4-carbon sugar. People have found a 2-carbon sugar in the past.
Yeah, where's the in-between?
Where's the in-between? Absolutely right. And I think what would be particularly interesting is if they can find this 5-carbon ribose in interstellar space, because this is what nucleic acids are made of. Obviously difficult to draw a line between sugars in a gas cloud near the center of the Milky Way and life on Earth, but it's one of these tantalizing things, and it's an interesting find that who knows where it might go.
Well, that's certainly a sweet discovery. And for my story this week, I have something that's got a little bit of a relationship because it's all about Mayan mathematics. And you may know the Mayans really liked looking at the sky, making calculations about how things are moving in the sky, and making calendars as well. It's probably one of the most famous things. And this is a story I was reading in Nature based on a paper in Antiquity about how one mathematician might have been a bit of a show-off and quite like some of the ancient masters.
All right, so the Mayan civilization then, where and when are we talking in this instance?
So the Mayan civilization spanned from 2000 BC up to the Spanish colonization in the late 17th century. But this particular study is looking at some texts from around the 8th century AD. And so this is based on analysis of a chamber in Zoltan, one of these Mayan sites that was originally excavated in 2011. And researchers were looking at this chamber and they found some calculations that were based on astronomical calendars, and they found that there were sort of playful expressions looking at the relationships between different calendar systems. And one of the authors behind this, I'm going to quote them here, said, "I think it was a mathematical flex. Someone was saying, I've got this amazing pattern and it's so good it needs to be written down." It was like, boom, mic drop.
Really? So as you say then, Mayans famous for their calendar work, and someone's just got these two calendars and said, I can see a pattern between these two, and just scribbled it down on a wall.
Yeah, basically that. So this is a particular set of texts that are referred to as text 19, and it has a bunch of hieroglyphs on it. So hieroglyphs, they're sort of like symbolic writing system that the Mayans and others used. And this one actually showed a relationship between several different calendars. So it looked at a 2,920-day cycle, which linked 5 Venus cycles, Venus going around the sun, 8 solar years, and 3 other Mayan calendars, and also Martian years as well. So it's described by the author as just super nerdy math, and they're doing this sort of fun notation that is like a shorthand. So it does kind of seem like showing off a little bit.
Really? So other than seeing that mathematicians were amazing, does it give any insights that researchers hadn't picked up on before?
Yeah, so this is the first time that a mathematical description has had a name attached to it. So the person who is taking credit for this, we're not sure if they actually wrote this specific hieroglyph or not, but the person named there is Saktan Wax, which can be translated as the white-chested fox. So this was someone, obviously quite proud of their notations. But the fact that the name of the writer is there suggests that mathematicians were recognised in the Mayan society as much as artists were. So maybe elevating their status somewhat. And this text, combined with previous discoveries in the Mayan civilization, suggests they had a really advanced grasp of mathematics. They knew how to do positional notation, advanced arithmetical operations, algebraic relationships. They had an idea of negative numbers and multiplicative factors. So there's quite a lot that they could do, which puts them on par with many sort of ancient mathematicians of the likes of Archimedes and that sort of thing. The only thing that we don't have evidence for the Mayans understanding is geometry, because when you look at their notations and things, there's no sign of geometry, even though some geometrical descriptions could give you more accurate dates for things like eclipses and things like that. So this civilization, who was very interested in calendars, very interested in the timing of events in the sky, the fact they haven't grasped geometry shows that they hadn't quite got there yet.
Goodness, what an exciting find, though. We love a math story, and that is an excellent one. Where does this go now? Is it looking for more of this?
I'm sure that researchers will be looking for more of this. It also just shows that perhaps the Mayans were a bit isolated, because a lot of our modern mathematical systems is a lot of passing back and forth between civilizations. So the Greeks got geometry from the Egyptians, then the Greeks gave that to the Islamic and the Indian world, and then modern day Europe got those mathematical descriptions from them. So we've got this sort of passing back and forth in Asia and Europe and that sort of thing. This could explain why the Mayans perhaps didn't get geometry, because they just didn't have this going back and forth between different civilizations like we've had.
Well, that is a fantastic story, and I can't wait to hear about the next Mayan mathematician showing off how smart they may be. But let's call it there for this week's Briefing Chat. We'll put links to both of those stories in the show notes, and a link where you can sign up to the Nature Briefing to get even more stories like this delivered directly to your inbox. But for the time being, I've been Benjamin Thompson.
And I've been Nick Petrichel. Thanks for listening.